This is the mock exam solution for chi-squared. Number 1, a university required all science students to study one language for 1 year. A survey was carried out at the university amongst the 150 science students. These students all studied one of either French, Spanish, or Russian. The results of the survey are shown below. Ludmilla decides to use the chi-squared test at the 5% level of significance to study the choices made. State Ludmilla's null hypothesis. Okay, so the null hypothesis, remember, compares two different factors and sees if they're related. The way you state it is you say the first factor and the second factor are independent. So in this particular case, the first factor would be gender, and the second factor would be language studied. So you'd say gender and language studied are independent. And that is what is known as the null hypothesis. If you wanted to make the alternative hypothesis, you would just say the opposite. You would say gender and language studied are not independent or are dependent. Write down the number of degrees of freedom and show how it was calculated. So remember that the degrees of freedom you calculate by taking the number of rows and the number of columns. So that would be number of rows is 2 and the number of columns is 3, and you would just subtract 1 from each. So you would do 2 minus 1 times 3 minus 1, which would give you 1 times 2, which is 2. So your degrees of freedom for a 2 by 3 matrix would be 2. Show how the expected frequency for the females studying Spanish is calculated and calculate the answer. Now remember that to calculate expected frequencies using the calculator, you don't need to total up anything, but if you need to show how the expected frequency is calculated for a certain category like females and Spanish, first thing you do is you say, okay, females and Spanish would be these two categories. And to do that, I'm going to have to figure out some subtotals. The subtotals for each one of these columns and rows. So for example, for the total number of the subtotal of the females, I would do 9 plus 29 plus 12. I'm going to do that on the calculator. So that would be 50. And males would be 31 plus 40 plus 29, which would be 71 plus 29, which would be 100. And then French, it would be 31 plus 9, which would be 40. Spanish would be 40 plus 29, which would be 69. And then Russian would be 29 plus 12, which would be 41. Okay, and so the grand total, if I add the rows or the columns, I would get 150. So to calculate the expected number of females studying Spanish, it would be proportional to the numbers 50 and 69 relative to the total of 150. So what I can do is I could do 50 divided by 150 times 69 divided by 150 times the number 150. And if I want to see what that is, I'll do that on the calculator. I'm going to do math. Let's see, math. And I'm going to go to number, and the bottom of the list there's something called n over d. If I have n over d, then it's a little bit easier to type everything in without putting parentheses around everything. I can just put the numerator, I could put the top three numbers, the numbers 50, 69, and 150 would be the numerator, and then the denominator would be 150 times 150. And the answer is 23. Okay, so that's how you calculate the expected frequency of 23. And now we're going to use the calculator to calculate the chi-squared test statistic for the data, and the way we do that is we use matrix. So we go second matrix, edit, matrix A, and we're going to make a 2 by 3 matrix, and then we're going to put in all these numbers. So for example, 9, 29, and 12 is the first row, and you see that I'm not making an extra row or column for the subtotals. I don't need to put the subtotals in because the calculator calculates those automatically. So I have 9, 29, 12, and 31, 40, 29, and now I can run the chi-squared test on that. I go stat tests chi-squared, which is option C, chi-squared test, and I'm going to say that my observed matrix is already programmed into matrix A, and my expected matrix is B. It's going to fill in my expected values there, and my chi-squared value is 4.77. Okay, and just for later use, the p-value is equal to 0.0923. Okay, now I'm going to go to the next step, and it says the critical value is 5.99. State whether Ludmilla accepts the null hypothesis. So give a reason for your answer considering the chi-squared test statistic. Well, according to this, the chi-squared test statistic of 4.77 is less than the critical value of 5.99, right? 4.77 is less than 5.99, so we accept the null hypothesis. Okay, and the reason that we're giving is because the chi-square statistic, which is 4.77, is less than the critical value of 5.99. Justify your conclusion above using the p-value. So using the p-value of 0.0923, the p-value is greater than the significance level of 5%. The significance level is the threshold used to figure out whether you accept or reject the null hypothesis, depending on the p-value. Okay, this you can do even if they don't give you the critical value. You can figure it out using the p-value. Okay, so using the p-value, I know that 0.0923 is greater than 0.05, which is the significance level, right, of 5% converted to a decimal. So I accept the null hypothesis. Remember that the p-value is kind of the opposite of the chi-squared value. The chi-squared value, when it's small, you accept the null hypothesis. When it's large, you reject the null hypothesis. It's the opposite for the p-value. So when the p-value is large, you accept the null hypothesis. When the p-value is small, you reject the null hypothesis. Let's go to the next problem. Brazilian holidays fall on each day of the week in a uniform distribution. Alexandre decides to study whether the data for the last 5 years satisfies a uniform distribution using the chi-squared goodness of fit test at a 1% significance level. Sorry about that. This shouldn't say female. It should say holidays. Okay. State Alexandre's null hypothesis and alternative hypothesis. Okay. So the null hypothesis would be that the holidays are distributed uniformly from Monday through Friday. Okay? And the alternative hypothesis, which we signify by writing H1, H subscript 1, we just write the opposite. Holidays are not distributed uniformly Monday through Friday. Okay? Write down the number of degrees of freedom. This is a little bit easier to do than a regular chi-squared problem that has a matrix, because when you have a chi-squared goodness of fit test, what you do is you just count up the number of elements in the row or column. In this case, it's 5, and you just subtract 1. So the answer is 4 for degrees of freedom. Makes sense, right? Because if you were going to fill in numbers to total up to a certain total number, you would basically add up, or you would fill in the first 4, and once you fill in the first 4, you're forced to calculate the last one to make it add up to a certain number, right? Write down the table of expected values. Okay, in this particular case, we know that there should be a uniform distribution here. We just need to figure out what the total is. So what is the total for this matrix? Well, 28 plus 22, that's 50, plus 12, that's 62, 62 plus 21, that's 83, 83 plus 17, it's 100. So the total here is 100. So if I was going to make a uniform distribution of 100 holidays between the days of the week, Monday through Friday, it would be 20 in each day of the week, right? So I would make a table where I would have holidays, and I would have Monday, Tuesday, Wednesday, Thursday, Friday. Each one of these boxes would have 20 in it because uniformly distributed. So that is my expected value table. Determine the results of a goodness of fit test at 1% significance level to find out whether the data fits a uniform distribution. Okay, so now what I'm going to do is, like, now when you do these goodness of fit tests, instead of using the matrix, you're going to use L1 and L2 because you're just putting in basically a column of data, right? So my data is going to be 28, 22, 22, 12, 21, and 17. And in this particular case, I need to tell it what my expected distribution is because it might not be a uniform distribution. And if it's not a uniform distribution, then how's the calculator supposed to know about that, right? So we're going to tell the calculator that in this particular case, it does happen to be a uniform distribution, but that's not always going to be the case. Later, when we learn about other kinds of distributions, we're going to go back and do a little bit more chi-squared, and then we're actually going to do problems where it is not going to be the same number repeated over in list 2, okay? So then I go to stat tests, and I go to chi-squared goodness of fit, and observed is L1 and expected is L2. And my degrees of freedom in this case, I said it was 4, right? And I calculate. And so my chi-squared value is going to be 7.1, and my p-value is going to be 0.131. Okay, and now let's check to see if that tells us whether or not we are uniformly distributed or not. So the critical value is 13.28. And remember, we compare the chi-squared value with the critical value, and in this case, it is less, right? So the 7.1 chi-squared value is less than the critical value of 13.28, so we accept the null hypothesis. So it is uniformly distributed, right? And then the reason for my answer is that 7.1 is less than 13.28. Says then give a reason for your answer considering the p-value. So the p-value is 0.131. The p-value in this case is compared to the goodness of fit significance level of 0.01, it is larger, right? So the p-value is larger than the significance level, so that means we accept the null hypothesis also, right? So you could use either the chi-squared value or the p-value to determine whether or not you accept the null hypothesis. The chi-squared value, just like in the chi-squared test case, you compare it with the critical value that's given to you in the problem, and then for the p-value, you compare it to the significance level, which is always in the problem, okay? Sometimes they may not give you chi-squared or the critical value. If they don't give you the critical value, you're forced to use the p-value to judge, okay? And on a IA, you will find your own critical value using very commonly found tables, which convert degrees of freedom and your significance level to a chi-squared value. That's it.